Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving find minimum time to reach last room 1. So the problem states that we are given a 2D array called move time, and every element in the 2D array will represent the minimum time in seconds when you can start moving to that room. And we will start at index 0, 0 or row 0 and column 0, and then we want to move to the bottom right of the grid. And we can move there by moving to adjacent rooms. And moving between adjacent rooms will always take exactly 1 second. So if we look at this example, we can go from 0 to the row under, but we have to wait 4 seconds. And once we're there, we will have to add another second because it takes 1 second to get there. And from 4 to 4, we don't have to wait, but it'll take 1 second to get there. So 0 to 4 will take 5 seconds, and here to here will take 1 extra second. So that's why we return 6. And we can also go from here to here and then come down. That will also be 6 seconds. So either way, 6 will be the minimum, so we return 6. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use the Dijkstra algorithm, and we will initialize a heap with this being the row, this indicating the column, and this indicating the time it takes to get to that place. And we will initialize the times indicating the time it takes to get there. So it will start with 0 here, and everything else will be infinity, but we will update them as we search through the rooms. So we will design a min heap, and then we will always pop the smallest element from the min heap, and then we will look to the top, the bottom, the right, and the left, and then we will add them to the heap. And then each time we pop from the heap, we need to add it to visit to make sure that we don't come here again. And then we will continue popping from the heap and adding to the heap until the heap is empty. So let's go over this example real quick. So first we're going to pop this since it's the only element. What we pop is our row 0, column 0, which is right here. And then we will look in the 4 directions, and we see that it takes 16 seconds to get here. So we add that here, 19 seconds to come here. So we add it here, and then we will update the times here. And then make sure we add 0, 0 to visit so we don't come here again. So now we're going to pop this from the heap because it's the smallest element, and that's at row 1, column 0. So we look to the left and bottom. There's no valid place. The top has already been visited, so we skip it, but we come to the right. It takes 17 seconds. So we update it here, and then we update it here. And then we also need to add row 1, column 0 to visit. So now we will pop this from the heap, and that is at row 1, column 1. And then we see that this has been visited, this has been visited. There's nothing here, but this will take 51 seconds. So we update that here and add it to the heap. And then we also need to add this to the visit. So now we will pop this from the heap. And as we can see, this is at row 0, column 1. And this has been visited, this has been visited, nothing here. But this will take 21 seconds to get there because we have to wait till 20, and then it will take 1 second to come here. So that's why it's 21. Update it here, add it to the heap, and add row 0, column 1 to the visit. So now we will pop this from the heap, and we see that this has been visited, this has been visited, and this will take 31 seconds. So we add it to visit, and we need to add it to the heap and update times. And now we pop this from the heap, and we see that it will take 32 seconds to get here because it will take 31 seconds to get here, and we need 1 extra second to come down here. So that's why we add that to the heap, and we see that this has been visited, nothing here, nothing here. So we add 0, 3 to visit, and now we're going to pop this from the heap, come down here. We realize that everything's been visited, so we don't add anything, but we just add this to the visit set. And now we're going to pop this, and we realize that the left, top, and right have all been visited, and there's nothing to the bottom, so we will not add anything to the heap. And now that the heap is empty, we will return what it takes to come here, and it's 32 seconds, so we return 32. So the time complexity would be O of nm log nm, where n is the number of rows and m is the number of columns, because we will search through m rows and m columns, and log nm because it will take that amount of time to pop and push to the heap. And the space complexity would be O of nm because the visit set, the times array, and the heap will all take up to nm space. So now let's get to the coding part. So first we will set rows to the number of rows, so it will be the length of move time, and the columns will be the length of move time of 0. That will be the number of columns. And now we will initiate times to infinity for everything, so times calls, and for I in range rows. But at index 0, 0, it needs to be a 0, so we set that one to 0. And now we can initialize the min heap, and we need to push 0, 0, 0 to the min heap, which is the time and row and column, and empty visiting set in the beginning, and then the directions will be where we can search. So we can search to the top, to the bottom, to the right, and to the left. So yeah, those are the 4 directions. And now we can go through the heap. So while heap is not empty, and TRC would be time, row, and column, will pop from that. And if the point is already in visit, then we will skip it. Otherwise, we will add that point to visit. And now we look all through all the possible directions from that point. So yeah, NR will be new row, NC will be new column, and it will be row plus a direction row, or NC plus a direction column. And if by any chance the new row is less than 0 or greater than rows, or if the new column is less than 0 or greater than the number of columns, then we will skip it and continue. And if that's not the case, then we can figure out the time it takes. So it will be the max of times RC versus the move time at that coordinate, and add that by 1, because it'll take 1 second to move over. And if time happens to be less than what we have currently there in the times array, then we will update it. So times of new row, new column will be equal to time, and then we can push that to the heap. So push heap and time, new row, new column, and then we will return the bottom right corner at the end. So it will be rows -1 and columns -1 of the times array. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave in the comment section, and I hope to see you all again soon.